Relatively quick set of notes this time. If you would prefer to do the type along version, then stop this video and do the other video. I just want to show you how you can use the Structure tab in IntelliJ to get a kind of table of contents of an already existing class. And then how you can write methods that take other objects as inputs, which is going to be really important in our class. I'm using the rectangle class solution from problem set, I think it was probably 4. The Structure tab is down here on the left. And when you click it, what it shows you is a kind of table of contents that shows you the attributes, the instance variables for your object, and it also shows you all the methods that are declared for your object. Let me show you actually in IntelliJ. So here I am. See my mouse, it's right here on the lower left. I'm going to click on Structure, and then I can use this actually as a table of contents. So I can say, I'm interested in the set size method, and I click on it, and it will automatically navigate the tab to the set size method. So you can use this both to get a sense of what is the object capable of, because when you're faced with a new object, really what you want to know is, what can I do with it? And the answer is, you can do all of these things. You can construct it, get the left side, right side, top side, bottom side, etc. So it's a nice way to just really quickly see what's possible, and then jump to those parts of the code. Okay, so let's imagine 2 methods. Let's process the code that's here already. So I have this useless array list, which I forgot to delete. I'm making 2 rectangle variables by using a method I wrote called random rectangle, which you can see declared here. So random rectangle returns a rectangle object. I create some random position variables and width and height. I use them to create the new rectangle and return it. So rectangle 1, so R1 is a new rectangle, R2 is a new rectangle. And to figure out which one is bigger, I will compare their areas inside main. I'll say R1, what's your area? Is it larger than R2's area? If so, R1 is bigger. What I want to show you is how we might rewrite this part. So instead of having main ask R1 for the area and ask R2 for the area and compare them, what if we leave the object in charge of deciding how it compares to the other one? So instead of typing this, we could type R1.is larger than R2. Think about it like a question. R1 is larger than R2. So this is going to return true or false, but it should do the same thing. This is a bit of a toy example. I don't think there's a strong reason to do it the way on the right rather than the way on the left. But it's just because the calculation is so simple. If the calculation to compare them were a lot more complicated, then you absolutely would want to put all the complicated logic inside a method, inside a rectangle. You wouldn't want to have your main method ask the rectangles for a whole bunch of information and then do a whole bunch of complicated calculations. Okay, so what does it look like to declare this method? Ta-da! In the main class, this is what we just saw on the previous slide. Inside the rectangle class, we'll say public boolean is larger than. Boolean because we know that the way we want to use this method is to return a true or false value. And then the kind of new part is the input that we take is a rectangle object. So you see I'm passing R2 as an input. R2 has a data type rectangle. So when I declare my parameter here, I'll declare it with a data type rectangle. I don't need to call this R2. This is just like any other parameter I might declare. So this could be called other, for example, to represent the other rectangle. And then what I want to do is still compare the areas. So I still want to ask, is the area of the first rectangle larger than the area of the second one? But now one of the 2 rectangles is the one actually running the code. So here R1 is the one that we're asking to run the is larger than method. So how do I get the area of R1? Well, right now, our code is being run by R1. So we want this object. Remember the keyword this? This is a variable that refers to the currently executing object. It's a reference to that object. So we're saying the object that's running this method, let's run that object's area. And now let's compare, is it larger than this other input object's area? And so if the executing object is larger than the past input object, we'll say, yep, we are larger, so we'll return true. Otherwise, we'll return false. An even shorter way to do the same thing would be this. The expression right after the return statement is the Boolean expression that used to be inside the if statement. So if I think about what is this thing on the right-hand side, it's going to return true or false. And that's what we want our method to return, exactly the same true or false value that this expression generates. Because if you remember from the last slide, if the if statement is true, we return true. If the if statement is false, we return false. So really, we just want to return whatever the if statement evaluates to be. And this is how you do that. So this is slightly more professional. It looks a little bit shorter, looks a little bit nicer. Let's do one more example of that kind. So let's pretend now that once we've determined which rectangle is larger, we want to center the smaller triangle on the larger triangle. So we want to actually move its position. So here, if R1 is larger, then we want to take R2, the smaller one, and tell R2 to center itself onto R1. In the else condition, if R2 had been larger, then we want to take R1, the smaller one, and tell it to center itself on R2. So again, we're programming by intention, by pretending that this method exists, imagining what we want it to do, and then we'll go ahead and implement it. So how would we do that? Inside the rectangle class, we would need to declare a method called centerOn. This method doesn't return anything, so it would be a void method. And just like last time, I take a rectangle object as my parameter. Only this time I've named it other. Okay, but it's maybe not totally obvious. How do you take a rectangle and determine what its position has to be so that it's centered on the other rectangle? So here is where, I think it would actually be great if you wanted to pause the video, draw a couple of rectangles, imagine them in a coordinate space, and try and figure out how do you need to set the upper left-hand corner of one so that the two centers are lined up. Because I think this is sort of a simple geometry problem, analytic geometry problem that you can probably work out. Fair warning, I'm about to show you with diagrams. So so this blue rectangle is smaller than the purple one, the way that we've defined smaller, which is area. So I want to imagine, how can I center the blue one on top of the purple one? Well, first let's figure out where's the center of the purple one. So the center of the purple one is here, and an easy way to find it is it's just the midpoint between the left-hand side. So the mid x value is the midpoint between the left-hand side and the right-hand side. So I'm taking the average. I'll take the left coordinate, I'll take the right coordinate, I'll add them, and I'll divide by 2 to find the average x coordinate. I'll do the same thing with the y's. All right, great. So now we know where the center is. We know where this one's center should end up. But the problem is we don't have a way in the rectangle class of positioning a rectangle based on its center. Remember, we can only tell a rectangle where its upper left-hand corner should be. So the real question is, if the blue rectangle is centered on the purple one, what are the coordinates of the upper left-hand corner? Hopefully you can see that if we are at the center x coordinate, all we have to do is subtract half of the width of the smaller rectangle to get to the x coordinate we want. And the same thing for the y. If we're at the center y, we subtract half of the height of the smaller rectangle. Again, I'm imagining our coordinate system is similar to the one that we use for our graphics library, where 0, 0 is in the upper left-hand corner of the screen. So subtracting y values actually takes you up. If you were imagining being in quadrant 1, like in a typical Euclidean plane and math class, then subtracting y values clearly would take you down towards 0. Either way, the point, it doesn't matter which coordinate system you use for the purposes of this assignment. What I wanted to emphasize was this is a case that's just barely complicated enough where you might need to draw some pictures. And these are the pictures that I drew. And then here's what it might look like to implement it. First, I'll calculate the center x as calculating... Oh, did I screw this up? Yeah, I screwed this up. All right, hold on. So I was going to pause it. Here's what I was thinking when I was deciding if I screwed it up. I was looking at other.left, and I thought, wait a minute, what is other in this case? And then I thought, all right, wait a minute. Oh, no, I didn't screw it up. It's right. So here's why you have to check all the time. Who is this object, and who is the other object? So center on R2 is going to be the smaller thing, and I'm trying to center it on the larger thing. So R1 here is the larger thing. R1 got passed inside this variable other. So other now represents the larger rectangle, which is the one that I want to center myself onto. So if I want to calculate the center coordinates, yeah, I do want to find the center coordinates of the larger rectangle. So I do want to say, let's find the average of the other rectangles left and right. Let's find the average of the other rectangles top and bottom. So now that's center x and center y. And then rather than set my own x and y attributes, I'm going to go ahead and run my own set position method, because that's what it's there for. So I'm going to set my own position to be the other rectangle's center minus my own width divided by 2, the other rectangle's center minus my own height divided by 2. So another lesson here is use the methods that are available rather than recreating them. That's it. This problem set will involve practicing a couple of new, implementing a couple of new classes, and practicing this sort of thing where you're going to make methods that take other objects as inputs. Good luck.